Let's look at the normalization of the ER diagram here. So let's apply the previous concept to this tune source case. Okay, let me read this sentence for you. All right. We described the rules of normalization. Actually, previous slide I already explained it, right? That help analysts improve the quality of data model. These rules help identify entities that are not represented correctly in the logical data model and entities that can be broken out from a file. Okay? So the result of the normalization process is that the data attributes are arranged to form stable yet flexible relations of the data model. Typically, three rules of normalization applied regularly in practice. Technically, in this example, we will address three rules. So 1NF, 2NF, and 3NF. Okay? We just describe these rules and illustrate them with the example here. So let's look at this figure. Zero normal form and one normal form, 1NF, right? And two normal form and three normal form, right? So these are the three steps, and in the slide actually I already gave you the more steps, but in this example let's look at the three steps here because those three steps are widely used in practice a lot. Okay, so do you from the zero normal form, so original data, and you should answer this question. So do any attribute have multiple values for a single instance of entity? If there's a case, then limit the repeating attribute and repeating groups. Create an entity that describes the attribute. Usually you will need to add a relationship to connect the old and new entities. And if you don't have any issue, the data model is in 1NF, right? So you need to resolve this problem here so that you can have a 1NF form. So 1NF here, or one normal form. So answer this question in these stages. In the next step, is the identifier composed of more than one attribute? If so, are any attribute value dependent on just part of the identifier? If you answer to yes here, and then you should remove the partial dependency, move the attribute to an entity in which their values are dependent on the entire identifier. And usually you will need to create a new entity, add a relationship to connect the old one, right? Old and new entities, so that you can have eventually you can have 2NF form, right? So 2NF, two normal form. And then once you have two normal form, then you should answer this question, right? Do any attribute value depend on attribute that is not the entity's identifier? If you don't have identifier, yes, then you should remove the transitive dependency or derived attribute. More the attribute to an entity in which their values are dependent on the identifier. Usually you will need to create a new entity and add relationship to connect the old and new entities. The data model is in 3NF. So now you can have 3NF. Okay, so let's look at this situation. So first normal form, 1NF. A logical data model is the first normal form if it does not contain attributes that have repeating values. So you need to focus on the repeating value in the same column, right? In this case, for a single instance of the entity, you know the difference between the instance and then entity, right? This is more like a template, like a customer, and then instance of an entity is what? Each individual, each people, right? Mike or Bob or Elisa and so on, right? Those people, right? Customers. So single instance cannot have repeating values, as you know. So often this problem called the repeating attribute or repeating groups. Every attribute in an entity should have only one value per instance for model to pass 1NF. See? Let's pretend that The TuneSource project team was given the layout for the CD purchase file that is used by existing CD sales system. Yeah, sorry, yeah, CD is too old, but anyway, still use a CD here. Right, so nowadays, yeah, you use MP3, I know. Yeah, the team members are anxious to incorporate the data from this file into their own system, and they decide to put the file into third normal forms to make the information easier to understand and ultimately easier for them to add to the data model for the new digital music download system. So see figure 6a-2 for the file layout here, right? So the project team received, yes, this is a file layout. So CD purchase and then purchase date. We have purchase date, customer last name, first name, phone, address, email, birthday, and then music preference. One more occurrence of CD, UPC, title, artist, label, category, price, total due, sales authorization, ship date, payment number, type, account number, authorization, amount, right? Ooh, yeah, many information. All right, you examine the file carefully. You should notice that there are two cases in which multiple values are captured for one or more attribute. Where? Here, right? The most obvious example is multiple occurrence of CDs that include in the purchase a clear violation of 1NF, right? Because it has multiple values, right? In the same category here, right? Why we have this problem? Because customer can buy multiple CDs, right? That's why. Okay, and each CD included in the purchase should be removed by creating new entity called the CD and placing all of the CD attribute into it, right? You need to have a one additional entity, seems like. The relationship between purchase CD is MNN, since purchase can include many CDs, right? And a CD can be included in many purchases, so many to many relationship, right? You remember this, right? Okay, second violation of 1NF may not be as readily noticed. The music preferences attribute include the kind of music customer prefer, classic, jazz, rock, and so on, right? The fact that attribute name is plural, so it can have multiple actually, multiple, yeah, preferences, right? Multiple values is a clue that many different preferences may be captured for each instance of the cell, and that music preferences is a repeating attribute. And actually, we can see the similar example actually in another case, right? If people say, if I say people, that means multiple person, individuals, right? Which is plural. So you need to worry about this 1NF issue. Yeah, this can be resolved by creating new entity that contain preference information. Yeah, and relationship is added between CD purchase and preference. The new relationship is also many to many because our CD purchase can associate with many music preferences, and music preference can be found on many purchases. See figure 6a-3a for the current data model in 1NF. See, so you can add the preference as well as city, and then we have many to many relationship, right? So now you can have, you don't have to have multiple values here, right? As a preferences, right? So now you can just make a many to many relationship between this entity and this entity. Same thing for the city. You don't have to worry too much about it. You can have just get the list of the cities, right? From this entity actually, right? Since we normally resolve the many-to-many relationship as EL diagram developed, we have done so now in figure 6a-3b. Now we have this one, let's say, and note that the new intersection entity. We have two intersection entity here and there. Preferred music and purchase city. Okay, to specify the actual relationship between CD purchase and preference, also CD purchase and city, okay? So that you can know, right? You know who buys multiple cities, right? From this table, right? From this entity, right? Also, you also can understand the preferences of the customer, right? Which preferences, okay? So from this table, this entity, sorry. Yeah, so note that a new intersection entity was inserted between CD purchase and preference to associate an instance of CD purchase with specific instances of the preference. Also, the intersection entity purchase CD was inserted between and CD and purchase CD purchase. This intersection is associate a CD purchase instance with the specific CD instances. You may wonder why I'm reading this kind of sentence because you are not familiar with my pronunciation. That's why I'm reading this. Okay, all right. If I just saying something and then definitely say something and then definitely some of you may not understand what I'm talking about because I have an accent and different intonation. So that's why. Yeah. Let me read this again. Okay. The attribute ship date was moved to purchase city because the various cities purchase may ship at different date. Therefore, this attribute describes a specific purchase city, not the entire city purchase. Mhm. All right, so let's look at the 2NF form. So second, normal form. 2NF required first that the data model is in 1NF, right? Once you have 1NF, actually, now you can consider the 2NF, right? The second, that the data model leads to entity containing attribute that dependent on whole identifier, right? So identifier issue. This means that the values of all attributes that serve as identifier can determine the value for all other attributes, for instance, and an entity. Sometimes non-identifier attributes are dependent only part of the identifier. Then that identifier shouldn't be selected, right, as an identifier. So partial dependency, and these attributes belong in another entity. Let's look at this figure 6A-4, okay? Showing the what? Showing the purchase data model placing in 2NF. So 2NF, let me zoom out a little bit. So, oh, sorry. Yes. So now we have a slight different shape of the ER diagram. So in this figure, you may notice that we have additional entities, okay? Actually slightly different from the previous 1NF form here, right? We don't have customer entity, but now we have customer entity, right? So let's look at it. Notice that originally the CD purchase, let me zoom in a little bit. So notice that originally the CD purchase entity had three attributes that were used as identifier: purchase date, customer last name, and customer first name. Let's look at the previous one. Customer date, customer last name, customer first name, right? Right. Oh, you're here. I'm sorry. You're here. Right. So where are we? Oh, yeah. The problem was that some of the attributes were dependent on customer's last name and first name, but have no dependency on the purchase date. Actually, purchase date cannot, you cannot use this information to specify the customer because one day you can have so many customers, right? These attributes were those that describe the customer: phone, address, email, birthday. So to resolve this problem, a new entity called customer, okay, customer was created, and the customer attributes were moved into a new entity. One-to-many relationship exists between customer and CD purchase because the customer can purchase many CDs, but a CD purchase is associated with only one customer. True. Mm. And remember that customer last name, first name are still used in the purchase entity. Let's look at this purchase date. Customer last name, customer first name. Okay. And you have three, and then here last name and first name is used in here, right? As in the customer entity. And then here is the information about to specify a certain customer, right? Right. We know this because of the identity one-to-many relationship between customer and CD purchase. The identifying relationship implies that the customer identifier are used in CD purchase as a part of its identifier, right? Notice that we move the relationship with preferred music to the new customer entity. Logically, a preference should be associated with a customer, not a particular CD purchase. Yes, so CD purchase CD, okay. So preference music, preference, yes, and the purchase CD, yeah. So no difference anyway. And so now we can move forward, right? So in third normal form, 3NF, occurs when the model is both 1NF, 2NF, okay? And when in other words, what does it mean? So we don't have redundancy issue. We remove the repeating values, right? For an instance of a certain entity, and then we don't have any identifier problem now, right? So that's why once you have both 1NF and 2NF, and then now you can work on the 3NF. And in the resulting entities, none of the attribute is dependent on non-identifier attribute. Let me just put dash here. Attribute and transitive dependency. A violation of 3NF can be found in CD purchase entity in figure 6A-4. Figure 6A-4. So this is 5. I'm sorry. And this is 4, right? Try to remember this. Okay? I will explain the problem with this sentence. So the problem with the CD purchase entity is that there are attributes in the entity that dependent on the payment number, not the CD purchase date, customer first, last names. The payment type, account number, authorization, and amount depends on the payment number. A non-identifying attribute, therefore, payment number, which is non-identifying attribute. So therefore, we create a separate payment entity and move the payment attribute to it. So one-to-one relationship, assume that there is a payment for CD purchase, and every CD purchase has a one payment. Yeah, payment here, right? So you need to create the payment from the purchase to indicate the one payment, right? Especially the indicate the purchase, CD purchase, right? Individual CD purchase. So one-to-one relationship assume that there is a one payment for every CD purchase, and every CD purchase has only one, so has one payment. Also, payment is required for every CD purchase, and then every CD purchase requires the payment. Oops. Yes, that's why one-to-one relationship should be defined, right? Third normal form also addresses the issue of derived, calculated attribute. Okay. By definition, derived attributes can be calculated from other attribute. Do not need to be stored in the data model because it will be calculated from the certain data, right? So from certain data, right? So you don't have to store the result anyway because you will run the program, right? So that's why program will calculate the value for you, or database system will calculate value for you. So you don't have to save that calculated value in your system separately. It will actually make your burden actually, or increase the size of the database system. So as an example, person's age would not be stored as an attribute if birth date were stored, right? You can easily calculate the age from the birth date, right? By knowing the birth date and current date, we can always calculate the age. You might legitimately question whether total due should be stored as an attribute of CD purchase, since each value can be calculated by summing the prices of all CD included in the purchase. Like much data of the modeling, there is no hard and fast rule about this. Many times, values such as a total due are included to serve as a control value in order to verify that no purchase cities are omitted from the entire purchase. The total value is stored as an attribute of city purchase, and the sum of the individual city prices is also computed to ensure that they match. Ooh, yeah. we will leave this. We will leave the total due. So why we have this kind of lengthy explanation, which means so you can keep some value, right, if you want it. By the way, so we will leave the total due, see, in the data model, and then model and show the final ELD in 3NF in figure 6A5. So here is a 6A5. I'm sorry, yeah, this one, and then we have total due here, right? And then so you don't. So according to this sentence, actually, they want to keep it, so that's why they have it, something like that, right? That's why they actually this sentence give you really lengthy explanation why they have the total due, and they want to use this information, right, to for the validation of the data, right, and purchase. So that's why. And as you can see, you can actually justify in 3NF, you can justify what kind of information which can be calculated should be also can be stored as a data, okay, in the data cell, data record as a data record. Yeah. Whew. Yes. So this is pretty much about the explanation of the real case. Okay, real case using three rules: 1NF, 2NF, and 3NF in ER diagram development. And let's do one more thing here. So we are going to develop in this case, let me provide the instruction of the new tool called, oh, sorry, called this software ideas modeler. Okay, and then freeware. And I already explained this model, actually introduced this model in chapter 1. So let me go back to the slide 1 here. Chapter 1. And at the end of chapter 1, you can actually see the link of the software. And if I click this, you can download the free software called the Software Ideas Modeler. And definitely it will help you to develop the ER diagram tool. And I think it is free for you if you are not using this tool as a commercial, to develop the commercial software. Okay? So in the class, you can use it as you can use a free software here. And let's open it. So once you install this software, you can see that this ER relationship diagram. Let me close it and then create a new project first. So when you create a new one, file, new project, and then definitely you can choose what kind of diagram you can use. Okay. So in this case, entity relationship, we are going to use the ER diagram. So this is the entity relationship diagram. So by clicking this, you can create the empty ER diagram space. And it's very easy to use. You can just drag and drop the entity here. Let's type the CD purchase here. CD purchase. Okay, and then let me drag and drop. And then you can add the other entity. And here you can have an attribute. By clicking add button, you can add an attribute actually. And add. Now this is a very nice software, specify the detailed information of the each attribute, including data type. But in this example, let me just type the name only. Cost, first name. Or so we have what? Add total due, and add sale authorization, right? And then primary key, and so you can use a primary key as well as foreign key, and this one customer last name and first name should be foreign key because this is a primary key for the customer table, customer entity. And let's use purchase date as a primary key for this entity. All right, and then now you have this is data type. So now you have this entity here. And what about next one? So second entity is customer. And if you double click this, and you can specify the attribute, right? And click add, cost, last name, add, cost, first name, add, cost, one, add, cost, address, click add, cost, email. Last one is what? Last one is cost, birth date. Okay, and then here's we have two primary keys. And we have relation here. Oh, so let me delete this. Okay, now we have two entities, and then we can have 5 more. So drag and drop here. And preferred. So preferred music. And double click this. So now you can see attribute and add cost last name. Okay, and add cost first name, add pre-type, and these two are foreign key, and preference type is a primary key. Click OK. And what else? Entity, another entity here, and preference, right? And if you double click this, and we have one entity called pre-type. Oops. And this is a primary key. Click OK. Right. And let me just reduce the size of this one. Oh yeah, and this should be, I need to change the attribute here, type of attribute. This one should be foreign key. All right. Okay. And what else? We have 3 more entities. And this one is payment. And we have many attributes here. All right. PMT, payment, and number. And this one is a primary key. And next one, purchase date. Next one, cost last name, and cost first name, and PMT type, and PMT account number, and PMT authorization, at PMT amount. So 1 2 3 4 1 2 3 4 5 6 7 8. Okay. All right, and then next one is purchase city attribute, purchase date, add cost last name, add cost first name, add cd UPC, add PCD ship date. And in this case, last name, purchase date, the primary key, right? And then cd UPC will be given by the next entity called cd. And here, actually, if we have link from the customer and then purchase the CD, and definitely we will have this one as a foreign key. But let me just set this one as a primary key right now, especially based on this example, the diagram shown in the example. Yeah, that's why you can have 4.5, 5.5, and so on, right? If there's any issues. Okay, add CD UPC, and this one is a primary key, obviously. And then CD title, add CD what? Artist, add CD label, add CD category, and last one CD price, and click OK. Right, so let me reduce the size of this and move this a little bit. Oops. Yep. Move this here. Right, and then you can create the relation. Oops. I'm sorry, this one. And border width, reverse direction, so the relation, and too many, and then and too many, and specify. Oops. Oh. It seems like I messed up. Okay. Oops. Yep. Let me delete this one. M too many. Okay. Oh yeah. Many too many. Many too many. One too many. One to one. And this one should be not many too many. This one should be many to one. Well, one too many. One too many. Right. Direction. Customer, parent, and child, purchase. So one too many, right? And what else? One-to-one relationship in this. Also one-to-one relationship. No, one too many. Sorry. One too many relationship between these two. And parent should be CD purchase will be parent, purchase CD will be child, and one too many. Oh, include, I didn't type the name in. So here you can specify the action, right? Makes, and this one, oops, this one you can specify the action, please. What else? Also, you can have one too many between this. So customer has a preferred music, okay, right? And then here, list action. We want a type of this. Yeah, I should use this one then. Sorry. So instead of this one, technically we need to use 1, 2, yeah, 0 and right, this one. I'm sorry, yeah, because there are so many different type of software, and that's why I got confused. Okay. Right. And then this one, 1, 2, and parents should be preference specifies, right? Let me move this one here. Okay. And what about this? All right. And then what else? Also, we have, yeah, let me delete this one. We have one-to-many relationship, purchase city, and then this one, oh, not many-to-many. I'm sorry, this is a mistake. One-to-many, 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 one-to-many here. And this one include, right? Case include, and 1 to 0, yeah, so this one, cd involves, right, and oh, this one I should, this one is not 0. Let me use 1 to n, 1 to many here, right, and the list. So now we have, yeah, all errors are fixed, I guess. So now we have, oh, I'm sorry, yeah, one more thing here. So 0 to n, customer by city, make a purchase month, okay, next. Here, pay, include, so something like this. So once you have this one, and then definitely you can actually print a screen this, where the get the save the file, and then extract this model. So for so the database development in future. But let me just try to finish the assignment quickly. So I just print screen, press the print screen, and then so that you can copy and paste this here. Okay. Yeah. Thank you.